Now, I already showed you how to use the leading coefficient test when your n is odd. So this time we'll show you how to use it when n is even. So if you notice, whenever you have an even degree, both your left and your right side of your graph are going to be either opening both up or both down. So that means that for both when x is approaching negative infinity or when it's approaching positive infinity, your f of x's are both approaching positive infinity or they're both approaching negative infinity. So whenever your x value is, or your a is positive, so if you have an even degree and a positive coefficient, that means your graph is going to rise to the left and the right. And then whenever you have an even degree and a negative coefficient, that means that your graph is going to be falling to the left and the right. So what we're going to do for example 3 is have a little mix of even and odds. We'll see if you guys can get these correct. So hopefully you tried these on your own for checking. You should always try these examples on your own and then check with whatever I have. That way you can see if you might have a little bit better grasp of the knowledge ahead of time. So for A, actually all these, let's just go ahead and set up the template. Alright, so if you look at where you have an even degree, you have a negative out front, that means that your graph is going to be opening down. So that means that both of your y values are going towards negative infinity. On example B, you have an odd degree, but you have a negative out front. And so what that means is your graph is going to be opening, or it's going to be starting from the top left. So that means it's going to be rising on the left. And that means it's going the opposite direction, so negative over here. And then finally, for example B, you have another odd degree function, but your a is positive. So that means it's going to be the opposite of B, which goes like this. Negative infinity falls to the left, rises to the right.